Hi all, welcome to Soumya's Tech Talks. So today in lecture 5 we will discuss on data types and variables. So we will discuss on primitive data types in C, NDNS of data types and variables and typecasting and some sample programs. Let's start. So we will discuss what is a data type and different C data types. Okay. So a data type is nothing but what are the different types of data supported by programming language. Like it can be a integers, floating point numbers, or byte streams. So we will discuss. You no need to worry. Uh, while we are going into further discussions, you will understand. Okay. So normally any data in the computer will be stored in binary, right? Like we earlier discussed, and that data is stored as group of bytes. So what is bytes? So we discuss how the data will be converted into binary, right? So binary is nothing but bits. So in that bit stream, so 8 bits as a group treated as 1 byte. So 8 bits is 1 byte. So the data is stored and retrieved as a bytes. Okay. So we will discuss more on this. Okay. So now if you see data types supported by C, there are two types. One is primitive. Primitive are the basic data types like integers and floating point numbers. So complex data types are group of primitive data types. It can be a group of integers, or it can be a primitive data types like combination like integers and floating point, some group of some integers, group of some floating point numbers. Okay, so those are called complex data types. Today we focus morely on primitive data types. So in further lectures we will discuss about the complex data types. Okay, so primitive data types. Okay, so normally primitive data types have a range. Range means what is the minimum number or minimum data it supports and the maximum it supports. So it depends on number of bits. For example, if you see integer types, so integers normally have two types. One is signed, which have sign like positive or negative sign, and which is unsigned. Unsigned means there is no sign, everything is positive. So if you go to signed integers, so the formula for the range, like what is the minimum supported number, maximum supported number, this is the formula. Minus 2 power of n minus 1 to 2 power of n minus 1 minus 1. Okay, so here n is number of bits that data type supports. So if you see integers, signed integers, you have char type. Char means character, and short, and int, and long. If you go to character type, so it has 8 bits. 8 bits, if you substitute in place of n, you will get this minus 128 to 127. So it only supports these numbers. So if you want anything beyond this, you cannot use the char. Okay. So next is short. Short supports 16-bit, and this is the range. And if you want anything less than these numbers, you can use the short data types. So next is integer. Integer, you can use int keyword, and it supports 32 bits, and this is the range. See how big it is. So if you want very large numbers, you can use int. And there is a very big data type in integer, that is long. Long is 64 bits, and this is the range. It's even more big range than integer. Okay. Now if you go to unsigned, so unsigned, the formula is 0 to 2 power of n minus 1. So you don't have negative numbers. Okay. If you see unsigned character, so it supports 0 to 255. It, it is same as char, but without negative portion, negative numbers portion. So same as unsigned, sort, int, everything. So this is same as this one, but no negative portion. So this is the range it supports. So the next one is floating point numbers. In floating point numbers, you have a float type, double type, long double. Like float is 32-bit, double is 64-bit, long double even supports more, like it can be 80 bits, 96, depends on the type of the system, which it can be a type of the processor, like Intel. You have different type of systems, right? Intel, or we will discuss. So our computers are normally Intel chip, right? So it can be support up to 128-bit long double. So this is the range. If you see 1.2 into 10 power of 38, this is the, you can compute using the, if you see 1.2 into 10 power of 38, and this is the negative and this is the positive. So we already discussed, right, floating point, how it will be stored in memory. So you can go to the earlier lectures for that, but right now you can only focus on, so you have a float, double, long double, and number of bits it supports and range. Okay, let's see. So today we also discuss about the endianness of the data type. What is a endianness and why it is important? So let's start. Let's take a unsigned sort. Let's say the number is unsigned sort 60,000. So 60,000, if you see, so 60,000, it will be first converted into binary. You can use a calculator. Like for example, you can see, if you see the calculator, right? So if you type 60,000, so this is 60,000. So if you see, this is the binary of the 60,000. Okay. So this is how you can check the binary format of any number. So 60,000 is first converted into binary. Okay. And then in binary, so there are two types. One is in this bit stream. So the right side, so right side is least significant bit. We call as least significant bit. And the leftmost bit is called most significant bit. Why this is least significant bit? We already discussed earlier. So when we converting binary to decimal, what we will do? 2 power of 0, 2 power of 1. The least one have the value, the value of the least one is 2 power of 0. So here, if you go beyond this, here you will get maximum 2 power. So if you have doubts, you can refer to the previous lecture. So why will convert the binary into decimal? There we discussed why this is least significant, why this is most significant. So for now, you treat that the the right side, rightmost bit is least significant bit, and leftmost is most significant bit. Okay. And if you see, when we are storing in memory, we store as a byte, right? So we will take 1 byte. So this is a group of 8 bits, which is byte. So the byte which includes the least significant bit is called the little end. So little end bytes. Okay. So, so here if you see, this is the least significant bit is part of this byte. Okay. So that's why the little end is this one. If you see the big end is this one, because this byte, it contains the most significant bit. So if you see the definition, the byte contains least significant bit, means rightmost one is little end, and the leftmost one is the big endian. Today we will discuss about little endian systems and big endian systems. So they are categorized based on how they store the binary data. Okay. So we will discuss more about that. First, let's discuss about the little endian system. So like earlier, we take the number unsigned sort 60,000. We know it will be converted into binary. So binary is the thing which stored in the memory, right? So if you see here, so like we discussed earlier, so each one has the least significant bit and most significant bit. Okay. So most significant is the leftmost. So right now, if you see, we have a 16 bits. right? So if your number is more, it can have 32 bits, it can have 64 bits, like that, right? So if you take any bit stream, so the rightmost one is least significant bit and leftmost is most significant bit. Okay, and as we discussed, little end, what is little end? The byte which contains the least significant bit is little end. So if you see here what happened in little endian system, let's say if you take a memory RAM, so this is the start of the, let's say this is the start of the RAM. So what it will do, it will take the and little end byte which contains least significant bit. First it will store the little end. Okay, and what it will do after that, it will take the next one, big end. If your data contains more bytes, more bits, like it can have 32 bits, 64 bits, then it will have more bytes. Then what it will do, from left, like left side, first little end it will store, after that next one, after that next one, and then finally it will store the big end. So if you see here, you can see first little end is stored and then big end is stored. This is called little endian system because it always stores little end byte in the memory first, and in sequentially it will store, at the last it will store the big end. That's why this is called little endian system. Okay, we discussed what is a little endian system and what is big endian system. Now let's see what is the problems because of this different endianness. Now, for example, take a computer which is big endian. So, and it is communicating with a mobile phone which is a little endian system. So both are different endianness. Okay. So if a computer, there is a software, okay, so which has a integer data type which is 25869. So you can see here it is it is a binary form of the this 25869. Now how it is stored in memory, you can see the animation. So first the big end, this one is stored. If you see next, the next one, see this next one is stored, and then next one. So now it is stored this one. At the end it store the little end. Little end means which contains the least significant bit. Okay, so now, so the same data, how how it is stored, will be transferred over the internet to the mobile. So the the systems or the components which is responsible for transferring data, so they don't know about NDNS. They just take the data from memory in bits and they will simply transfer like this. So your data will be transferred like bit stream into other side, irrespective of what kind of data, what kind of NDNS. It just whatever stored in the memory, it will be stored like this. Okay. Let's say you receive all the data. Now I received all the data. But for example, what happens here? What is the problem? Here, the data in the computer is stored in the big endian notation, but the phone supports little endian. So, so the big endian data is stored, it is not aware of this. And let's say there is a software program in the mobile. As you see, there is a software program. Whatever data transferred here, it try to fetch the data to a integer. Okay, and this binary data, what is fetched here, will be converted to a decimal number, right? So we already discussed how to this how to convert a binary into the decimal. You can see, you can use a calculator and convert. So why, but here it came as different number. So we saved as 25,869 in big endian, and it is transferred to uh, the mobile and it is fetched. But the mobile is little endian. Due to this, the data is completely different. Okay, which leads to some software errors or system errors. Okay, so why it is different? If you see the computer storage big endian, so it is, but the mobile is little endian. So the ends are different, right? So the data is completely reversed. And due to the reversal of data, you can take this data and use calculator, so this data you just reverse it and see this number will come. So why it is reversed in mobile? Because it completely the NDNS is different. So due to these kind of things we need to see. So when we are dealing with different systems with different NDNS, so we have to first fetch the data and then convert into right NDNS and then convert into the decimal. So these things we will discuss in the further lectures, but today just I want to explain what are the different problems arrive due to the systems which communicate over the internet or over the any network which have different NDNS. So that's what we need to discuss today, and how to solve this problem we will discuss in the further lectures. Okay, so we discuss about data types. Now let's discuss is variables in C. So variables is nothing but, let's say you have a formula, algebraic equation like a plus b whole square equals to a square b square 2ab, right? So this is the algebraic equation here. So a is a variable and b is a variable. You can substitute lot of numbers. You can substitute 1 in place of a and 2 in place of b and check whether the equation satisfy or not. So like how in algebraic equation you have the variables, like you have a represent either a b or xy, right? So like that a programming language also you need a variable. Variables are nothing but you have some variable data on which you can give a lot of inputs to that variable and do computations. Okay, so variable is nothing but the data will be changed continuously with different data, and the operation will be performed and result will be checked. Okay, don't worry, we will, while going through the lectures you will understand. So now let's see how to create a variable in a C program. So the syntax is, so data type you have to tell what kind of data type it is, like earlier we discussed, and you have to give some name, like here AB, you can give some name to variable, and you can initialize, like you can give initial value of that. Like here I define a integer variable, like int is a keyword, and I give name as a and I assign to 10. Okay, so or you can directly declare like this int a and you can assign it later. Don't worry, so what don't confuse what is this, and if you are beginner, we will do a lot of programs and you will understand how to do this. Okay, now let's discuss a small program. Okay, in this, so there are something like this one include and then some printf. Don't worry, we will discuss, but right now just to explain the concept of data types and variables, I have written this sample program. You can follow as it is if you are beginner. And what is this includes, and this printf is to print or to display some message. So these things we will discuss more deeply further, but right now we will focus only on the data types and variables. Okay, so this is the program. So here I have declared some variables. So this is the char data type, this is the int data type, this is a float data type, and I have given different names a, x, y, and I have assigned some values, and here I am printing the value of a, the value of x here. Here I will print the value of x, and here I will print the value of y and z. Okay, and let's debug this. You have to go here, run and start debugging. Okay, now as you can put click here to add a breakpoint. Okay, so we will here it stop, program is stop here at the breakpoint. So here I am declaring a variable which name is a, the data type is character, and the value I am giving initializing is 16,345. Let's see what happens here. If you see, so now this statement is executed, but if you see the value of a, that is not 16,345, but it is showing as minus 39. Why this is happening? Because the range of character is, as we discussed, minus, it's only support from minus 127 to positive 128, but you are assigning which is the number which is beyond that. That's why you are getting the wrong result. So that's why you should be careful while assigning. If you want to use a char data type, then it should be, the data will be very small, which is less than, which is greater than minus 127 but less than positive plus 128. So anything beyond that, you should not use the char data types. Let's say here, if you see the terminal, it is printed, but it is printed, not printed this one, but it is printed something else, because this char data type is not fit this much big number. Okay, now I have another variable x, I assigned same thing, but if you see x, it is correct, because x is a integer which its range is very big and it can hold this 16,345. So if you see, the value is properly printed. So now here I have created a floating point number, and the variable is y, name is y, and I assign the value this one. If you see, this is also correct. But if you see, I have created a integer variable, the data type is int, the variable name is z, and the value I am giving here is 132.56. but if you see, the z value is just 132 only. It lost the value after the decimal point. Why? Because it's, the data type we use is integer, it cannot take the decimal, the floating numbers. So if you want floating numbers, you should definitely use either float or double or long double. But if you use int for floating numbers, you will go, lead to the wrong result. So this is the program. Okay, this is our short program. So today we will end the lecture. Today we will end the lecture and about the C variables and data types, and we will continue further lectures on the C programming language. Until then, bye, happy learning, and don't forget to like and share this tutorial to your friends who are willing to learn C programming language. Bye to all.